Hello, everyone. Thank you all for coming for this talk. I'm Nishant Srivastava. I'm an Android engineer at Soundbringer, working in Berlin, Germany. Today, I'll be talking about things I wish I knew when I started building Android libraries. You'll notice there's a label here that says Volume 2. That's because the first iteration of this talk I gave in Droidcon Berlin last year. It's been over an year now, and I know more stuff, which is what I'll be sharing with you guys. So I love building Android libraries, which is visible in all the open source work that I've been doing. I build all these open source libraries. And then I also build those for, as a closed source version for companies and for clients and other people who would want my services. While doing all that process, I figured out a couple of things which is not visible on the internet, or maybe it's really hard to get it. And I will basically be covering some part of it, but there's usually more stuff around Android libraries when you start building those. So here's an overview of things that I will be covering today. So there's 12 points. We'll just breeze through them. They're super easy, don't worry. I'll make sure they are super easy. So let's start with the basic question here. That is, how does Gradle process the Android libraries? So in general, how Android libraries work is that in an Android app, you would have a repository section, and then you will have a dependency section. This dependency section has this keyword called implementation, and then the signature of the library that you are adding as a dependency. So it will say the package name com example.myawesomeLibrary, and then the version number for it, so 1.0.0. Now, the implementation word or the keyword is important here because it works in a different way when you are pulling in the libraries. So we'll take an example here. You have an app module, you have a library A module, and you have a library B module. Now, the way the hierarchy is working here is that the app references library A using the implementation keyword. It says, I'm going to reference library A as a dependency. Then library A goes on to reference library B as a dependency using the implementation keyword. Now, here's the thing. Because app is referencing library A, and library A is referencing library B, there's a scoping happening here. So this keyword is specific to Gradle. It came after version 4.0, and it does sort of a scoping state here. So app is not able to see library B, but library A is able to see library B. Herein, what it means is that the module that references the other dependency is only able to see it. If app does not implement library B, it will not be able to see the classes available from library B itself. Now, turns out this is a very good version of doing things, but in the real world, there are different ways that you would actually want app to reference library B classes too. So Gradle provides another keyword called API, which is almost the same as how you have been doing earlier. You use the compile keyword. It's almost equivalent to that. Herein, the same example applies. App is referencing library A with the API keyword, and then library A goes on to reference library B with a dependency keyword using API. In this case, though, app is able to see all the classes in its class path that are there in library B. OK, so this covers the general rule of how the dependencies are getting pulled in. There's a third keyword which most people don't know about, and this one is called compile only. Now, compile only is supposed to say that the classes are available in the class path when the compilation process is completed. So in the same example that we are talking about, you have an app module that references library A module with an implementation keyword, and then the library A goes on to reference library B module with an implementation keyword. Now, here's the change here. Library B has another dependency on library C, but with a keyword called compile only. So what this means is that when Gradle is going to be running through or trying to download all these dependencies, it will not go and download library C because of library B. What library B is asking you right now is that it needs to have library C compiled pre to it going on to download its own dependency. So what, as developers, we would have to do is, in the app module, you need to implement library C. How does this work now? Now, app is implementing library C, and app is also implementing library A. So both these dependencies are downloaded before library A goes on to download library B. So at the time library B is available, you have the library C already in the class path. So that's some way of how Gradle is processing the Android libraries. It's downloading those dependencies. Now, here's the thing. The most fundamental thing about Android libraries is Android Archive. the same way as you have for an Android app. It's called APK, which stands for Android Package. Android libraries are bundled as Android Archive, or you can, in short, call them AAR. And what exactly are Android Archive or AR? They're basically Java Archive plus resources. These resources can be anything. They can be your, say, native libraries. They can be your dimensions, strings, anything that you put in your resources folder. And that works like out of the box. But here's the thing, it's all theory. And this is not how I try to understand things. I try to tinker with things, and I try to find out how these things are actually working. So I want to see this live, or like doing a practical experiment to find out how is this true. So I took a library that I built called Sensi. And Sensi basically what it does is it basically allows you to handle gestures using your sensors in a much simpler manner. Like say, for example, you're doing a wave gesture or you're flipping your phone. All these kind of things are super easy to do. So I took that, and I took the AR of this Sensi library itself. Now, since it's an archive, I thought that why not just rename the extension of AR to .zip and unzip this. As soon as I unzip this, I see all the files that the AR contains. It contains the classes.jar, the Java archive I was talking about. And then there's a res folder, which probably would contain all the resources. And then there's a JNI folder, which will probably contain other kinds of like native libraries, compiled libraries. And also libs folder, which might contain other jar libraries too, which is good to understand. But here's the thing. Let's go back and check out Sensi's build.gradle. Now, this is inside my own project. It's not a published library. It's a library module where I can define the implementation keyword. And this is like a transitive dependency. So anytime Sensi is downloaded, the support compat library will also be downloaded. So it's a dependency for my Sensi library too. This thing makes sure that at any time support compat will get downloaded. But we are talking about AR, right? So it's a bundle that I can basically, or in theory, I can send it over an email or to someone, and they should be able to use my library, right? How do you actually do that? Well, you need to define the path as a flat directory in your repository section, the way we were doing with JCenter, with Maven Central, or any other Maven repository you might have. And the dependency section, you just put the implementation keyword, pass the name of the AR with an extension AR itself. I did that, and I sent it over to a friend, and something happened. None of the transitive dependencies were downloaded. Like support compat was not downloaded. It gave an error saying that there's no support compat available because of this kind of a question that comes up, like why doesn't my AR download transitive dependencies? So let's go back and check the AR again. It doesn't have a build.gradle file. So there is no definition of a transitive dependency. So like how is Gradle able to download all the other dependencies when you include any other dependency in your app module, right? So this is where the concept of Maven artifact comes into place. A Maven artifact is like a wrapper on top of an AR. It includes like sources, your Java doc, and your AR file, and other kind of configuration files you might need. And then this is pushed over to Maven repositories such as JCenter and Maven Central. But again, I wanted to find this out, like, is this even true? Like, is it a wrapper on top of my AR? So I went into JCenter. For me, it's Bintray, which is the one that serves the JCenter for me. So this is where Sensi is hosted. And I looked into the file section. So as I go through the files, I see there's a Java doc jar file, there's a sources.jar file, and then there's my AR, which is what we have been talking about. But there's something weird here, something called sensi-1.8.0.pom, POM file, which stood out. So exactly what is this POM file? Well, POM file is a project object model, basically an XML file containing configurations required for building a Maven project. So as I looked through this, I wanted to check this out. What kind of a file is this? What does it contain? So I looked into this one, and there's a bunch of code in there, right? This is all XML code. But I want you to focus on this section, which we can also zoom in. And this is the place where the transitive dependencies are defined. So technically, if you ever wanted to give your library out to someone else, you shouldn't be sending over an AAR file because it will not have information about your transitive dependency. It will not download any of those transitive dependencies. But if you package it as a Maven artifact, there will be a POM file that will contain the information about transitive dependency, and your library will download the transitive dependency. which is like mostly how people actually work. This is how you actually use your something called Maven Central or JCenter. You push it out as a Maven artifact, and then Gradle pulls them in. Because we are talking about bundling things, so I want to also bring up this thing. But I'll first talk about the problem here. So ProGuard, as we know, is used for obfuscation. It's used for optimizing the code. So in general, the problem here is that as an app developer, if I get a library, I'm going to include it, and I'm going to run ProGuard on my app. Now what happens is that at that particular point in time when ProGuard has executed, during the obfuscation phase, it might change the name of the class files. That being said, if the library was using reflection, would cause the library to break. Now, it's not that simple. A library never executes on itself. It breaks inside the app, so the app is breaking. Your app is crashing. You are seeing all these crashes because a library's code is not functional anymore because you obfuscated. So the usual way people do this, as a library developer, I would go in and I would run ProGuard on my library, and I would make sure that everything that is getting obfuscated is actually kept into the library. ProGuard does not obfuscate them. So I write these specific rules in the ProGuard rules file, and I give it in my README. Someone has to copy this and put this into their app, which is a very lengthy process. So how do people avoid that? Well, you bundle it right into the library itself. So how does this work? Like in general, when you bundle it up, this file is not added to the app. It's actually appended to the app's ProGuard rules file. This is important because I'll tell you why this thing causes more problems than it solves it. But it is a possibility to have ProGuard files with the specific rules defined in your library to get appended to your app's ProGuard rules file. And when it runs, it basically just keeps all your classes in the library. So to do that, I also wanted to check this out. So I went to another library. This one is called Fuel. And it's basically used by people who are using Kotlin. It's almost equivalent to using Retrofit, used for networking and everything. And this library has this specific configuration called consumer ProGuard rules file, and it defines a file and a rule. So I went in, I checked out the AR file, unzipped it again, and there is a ProGuard.txt file. So it's basically bundling it inside the AR file itself, which is great. I want to check this ProGuard rules .txt now, and it has a very specific line that says, keep this particular class, that is Android environment here, because without it, it's basically none of the callbacks are going to work anymore. So this gets appended to your app, and when you run your application through ProGuard, these files are kept, the library works, the app works, everything works, you're good. How does it goes wrong in a different direction? Well, we can talk about that, but before that, say for example, if you were gonna be doing these kind of merging, like appending, how do you wanna see that? Well, you put this rule called print configuration, and then the name of the file, and it will give you the merged version of your ProGuard rules file. Otherwise, you won't ever see this happening. This happens during the merger phase, the appending of the ProGuard rules file. But how can this go wrong? Well, if the library developer decides to add something called don't obfuscate, optimization, disable code allocation and variable changes, and also basically says keep the public classes which have public protected methods, keep them all, don't optimize them. Think of this. This rule is coming from the library. It's being overcautious. This rule gets appended to your app's ProGuard rules file. Now, none of your app's code is getting obfuscated. None of the optimizations are running on your code allocation or the variable optimization that is possible. All the public classes with public protected methods are not getting optimized at all. So essentially, even though you ran your ProGuard tool, your app is still the huge mess that you were looking at. It's not cut down into size, so it's still there. It gets worse. If someone adds don't optimize, ProGuard is literally not running there. So you don't know what is happening because you run ProGuard and it executes through completely, but there is no reduction in the size of the app, and there's no obfuscation happening if you look into the code back again. So that is why this is more of an ethical thing. As library developers, we don't do this. But if they do, it is a good thing to do on the app developer side to always check the merged version of ProGuard rules file. If something is glitchy and you don't understand why this thing is happening, go and check what happens during the merger phase. It's mostly during the merger phase that things will show up magically or they will go away magically. And we'll see that in the next slides also, where merger phase can cause problems. OK, so this is one of the other things that I have experienced, modelization. I call it modularization, but it's like basically splitting your library into different parts. I'm pretty sure people have seen this. This is Google Play Services. This is a screenshot that I took quite recently. And at the top, there's a note that says, don't use the combined Play Services target. Why so? Because sometime back, Play Services was just one library. Eventually, it started to grow into size, and it became so big that if you include it, you had to include, like, enable multidexing, which is really bad. You don't want to do that. So what they started doing was they split it into different sections, and only based on the feature you want would you be using a specific kind of a library dependency. So say if you want only Google Plus functionality, you will use the Google Plus dependency. If you want Google Accounts login, you can just use the Google Accounts login dependency. Now, while I was looking at that, I was thinking that if I wanted to do this on my own, how would I do it? So turns out I have a similar kind of problem in my library too. And this one is called Easy Device Info. I built this library, and this library is basically used to get device information. One of the things that it does is it tries to pull advertiser ID. Now, to get advertiser ID, we need to have Google Play Services, because that's something that's like a proprietary API. So what I did was I basically, every time I would give this library or someone would use my library, they would pull in the Google Play Services too, which is really bad because some people just don't want ads ID. They want other device information, but not the advertiser ID itself. And even though they don't want it, they are still pulling in Google Play Services. They couldn't avoid it. So this was a very good use case for me to split this library into two parts. One that would be used for ads ID, and the other one for other kinds of basic device information. So this is what the README and the section of including the library looks like right now. I have something called the ads library. It says easy device info -ads. And then I have a base library, which is basically using every other kind of device information you would need. And then there's a top-level library, exactly like Google Play Services top-level library, wherein it will include the base and the ads library too. But I was building this. I also wanted to make sure how this thing was working. So what we are going to do is we are going to look at the POM file for this. So again, the POM file, I've shortened it out to the section which is important, which is the dependency section. And there you will see, this is for the top-level library I was talking about. There's a dependency on ads library, and then there's a dependency on the base library. What this also means is that I had to publish ads and base as individual libraries. Because essentially, when Gradle runs, it tries to pull in what is already available on Maven Central. So if this existed in my library code, or like as a different module, but it was never pushed to any other Maven Central or JCenter repository, Gradle would never know where to pull this from. So I publish ads as a different module, and I publish base as a different module. Then I published my last top-level library by referencing them as, say, in this case, implementation ads, implementation base. And then when the POM file is generated, this is how I get this. OK, because I was talking about the ad section, so I also want to show you the section how this was pulling in things. So there's something called easy device info -common, and then there's a play services -ads identifier. So only the person who includes my easy device info -ads library would be pulling in play services, otherwise not. An important thing here again is that there's something called easy device info -common, and that was not in the section of including a library. Where did that come from? Well, technically, this is also a library that is published on the JCenter, but the thing is that it just contains common code between ads and base library. I needed some shared code, so I put it there. It doesn't do much, which is why it's not there in the README file for the library integration. But technically, someone wanted to do this. If they look at this POM file, they could easily include the easy device info -common library individually too. So it's totally possible. Every time you want to check out something that, OK, where's the hidden information about the library? It's in the POM file. It's not in your build.gradle. Build.gradle works on your system. It does not work when it's out of your system. OK, so this problem is something that I encountered while I was working for a company in Amsterdam. And this was more like a freelance project. But the idea was that the app developer basically have something called a resource name, like a string resource, and they will put a key name, say, for example, key_1. And as library developer, I build a library which also uses the same resource key name, saying key_1. Now, that's a conflict because when a merger phase happens, there are two strings with the keys called key_1. That doesn't work. So we're going to take this example of when the conflict actually happens. But before that, we also want to understand what actually happens in this case. So say, for example, the app developer has the same key. The library developer also built the same kind of keys. And when they both conflict, the project will not compile. It gets worse when there are two libraries that conflict, but it's not conflicting with the app anymore, but there are two libraries that are conflicting. The library A has key_1 as a string resource. Library B also has a string called key_1, and they both conflict. Then the resource that is defined at the top in the dependency section is the one that brings in the resource, and the other library is supposed to use that resource. That's a big problem. Now, library B is not meant to handle this kind of a resource key. Even though the key value is same, the value might be different, and it might be reacting differently, so it will cause a crash. Again, the crash probably happens in the library, but it causes the crash in the app. You never see a library ever crashing. You see the app crashing, because that's where the code is executed. So what's the actual solution for this? Well, the solution is that you add a prefix to all your resources. This being cautious, you do that upfront. You can enforce this by putting this in your Android Studio, like build.gradle, in the Android configuration part. You say resource prefix and the prefix. So this is again theoretical. I wanted to do this. I want to check this out. So what I did was I added resource prefix to my library module and saying sensi_. And when I go and declare app_name is a pretty common string resource in app, so I try to declare the same thing. It gives me an error which says resource name app_name does not start with the project's resource prefix sensi_. Rename to sensi_app_name. It gives me a hotfix. It assessed me. It will not do it automatically. So it's a good thing to do this. As a library developer, it is something that people don't take care of. I've seen this a lot of time, and resource conflicts happen. But this is a good way to avoid that. OK, so this is another of the things that I figured out like while doing something for a company. And this one is called a main SDK restriction. And this is like an unsaid rule. I don't know how many of you know about this, but this main SDK restriction basically says that main SDK of the app must be greater than or equal to the main SDK of the library. Now, what that means is, say, for example, your app is API 14 and the library is 21, then the main SDK restriction comes into place and the project will not compile. We can see that because I tried to do this again with my library, and I changed the main SDK to 21 for my library, and for the app, like the sample app, I changed the main SDK to 14, and I get an error. The compilation doesn't go through. I'm going to zoom this up. So what it says is, it says manifest merger failed, uses SDK, main SDK version 14 cannot be smaller than version 21 declared in library, and the name of the library itself. Where is this a restriction being implied on? It gives me some suggestions. Some of them, which are like the first two, are useless because it says use a compatible library with a main SDK of at most 14, basically saying replace the library with another library. Sometimes this is not possible, it's not practical. Maybe it's the only one library that is doing that kind of functionality. There are no other libraries, so you can't do that. The second one is totally unrealistic because it says increase this project's main SDK version to at least 21. So imagine you as a developer, you get into the state and you want to figure out how to do this. What they are saying as a suggestion that you change your main SDK to 21, thereby foregoing any other API version which was being supported for your users. So 14 till 21, all users don't get any updates anymore. So it's basically useless. But what is important is this section, which says uses tools override library and then the package name. So what this is basically saying is that you are enforcing as an app developer that you understand this restriction and you're going to be using this feature irrespective, and you want to bypass this rule. Now, in the bracket, I also say may lead to runtime failures. It's because, say, for example, I bypass this rule, and my app is 14, library is 21, and I bypass this rule. Now, when this app is running on an API 14, for example, the library does not support anything that is below 21. So it might lead to crashes. It doesn't know how to handle API 21 and below. So this is why it might lead to runtime failures. How do you use it? Well, in your app's manifest file, you literally just go and use SDK, tools override library, and then the library name. I don't know how many of you have seen it, but this was pretty common sometime back when Google maps library was causing these issues, and they were getting pulled in for some reason. They didn't update their min SDK, so people would use this override library to bypass this rule, because they were not using the maps library at that time. Again, place services was just one library at that point, so you had to override it some other way. Okay. Now, the next thing that I'm going to be talking about is more related to the access visibility versus code organization. Now, this is a very debatable topic, but mostly what I'm talking about, how do you organize your code when you're building a library? In general, how it works is that people organize their code into individual packages and make everything public, which is not a secure way to handle things, because now the app can access your internal classes, and it's really bad. The other version of doing things, which is the most recommended way right now, is that you have one package, you make everything package private, and you make only the specific classes you want to be public. So it's like public on demand. I just want one class to be public, everything is being accessed by this public class internally. So none of the app can access those internal classes. So it's a good version. Mostly Sensi follows this, Easy Device Info, and all the other libraries that I've built, they all follow this. And a lot of other production-based libraries also do this. But then Kotlin came in, and it did something. It gave you the ability to organize your code into sub-packages. That was the first point, and at the same time, be able to be secure. So when you add an internal keyword instead of private, public, protected, or just the default, if you add internal, what it means is that your code is visible inside the module. Like the whole folder, it's visible inside that. So you can have your code in sub-packages, and they can each talk to each other, and they will still not be available outside the module. So it's a good thing. The drawback, you need to have a dependency on Kotlin standard library. That's because you are using a standard library keyword here, internal, which probably adds method counts, some sort of processing time when you are downloading this or running this through compilation. Here's an example of how this thing works. So you have a standard package, com.example.library, and then you have the private function, which is only visible inside the example library.kt file. You have a public field, which is visible everywhere. But when it comes to internal, it's visible only inside the module, like the folder itself, and not outside that. So no one can access outside this module the variable called debug tag. But inside the library module, you can access it within packages, outside the packages, everywhere. OK, so this is some sort of experiment I did. We all know about the lifecycle components, right? We also know architecture components, and lifecycle components are basically part of it. And these are basically classes defined to let you handle the lifecycle of fragments, services, or your activities, anything that is a lifecycle owner. So basically, they have three classes. They have something called lifecycle, lifecycle observer, and lifecycle owner. How do they work? Well, this is like a very generic diagram, but lifecycle owners basically have a lifecycle. There's like an instance. This instance keeps track of which state the lifecycle owner is in. And any change that happens on this instance, the lifecycle observer is able to observe that. Like it knows when that lifecycle instance value has changed. We typically know what lifecycle owners are because those are activity, fragment, service, custom, any other version that you might have. But I was not convinced, so I went in. I tried to check how is this possible. So turns out that main activity extends app compat activity. And then there's this app compat activity that extends fragment activity. Fragment activity goes on to extend support activity, which has another class called lifecycle registry to pinpoint the states where the lifecycle is changing. But what is important to us is that at the end, there's something called a get lifecycle method, which allows me to get the lifecycle of the activity. This is what we use eventually. Now, the idea is that now that we have the lifecycle, we want to observe this. And this is how people make lifecycle-aware other kinds of objects. But I wanted to make my library as lifecycle-aware. Why would I want to do that? Well, typically, how people do this is that they would have something like when you go on create, you initialize your library. When you go to on destroy, you clean up your library, right? You call this cleanup method and destroy everything up. So that's how people do it. But I want that to be taken away from the app developer side so that they don't have to write this line. And only the first line where they write it, the observation happens, and every time a specific method needs to be called at a specific lifecycle event, they get called automatically. So I want to do that. So how do I do that? Well, I try to convert my lifecycle my library into a lifecycle observer. To do that, I had to include these dependencies. There's this dependency called Android X lifecycle runtime and then lifecycle compiler. And then for my library class, I go and implement the lifecycle observer. Lifecycle observer is an empty interface. It just marks that it's a lifecycle observer. And then for every kind of method, I mark when they should be triggered. So it's going to happen automatically. I'm just going to marking them by saying on lifecycle event, on create, trigger init. On start, trigger lib on start. On destroy, call the cleanup method automatically. So in my main activity, I basically just initialize my library, and I go on, in my on resume, I say add the observer on the lifecycle, which is my library here, and then on stop, I say remove the observer. So there's no memory being leaked, because as the activity goes in and out of these on resume and on stop, the observer is going away, as well as it's being added and removed, so it's not lurking around with the context of the activity anymore. The library section here is not like a random keyword here. It's coming from the get lifecycle, but in Kotlin, it's like a property, so it's called lifecycle straight up. So this was my experiment, which I did. Turns out bigger companies or other developers are also doing this. This is from Picasso, a library that is like everyone knows about it. It's used for getting images over the internet or like caching and everything with the bitmap. They recently merged this in August 20 by making the library as lifecycle-aware. So it's not just like a random thought. I definitely wrote the blog post, I think, in March this year, and now everyone is going forward with this. So it's not a bad idea. It's a really good one. So while I was actually working with this, I found something, as in this thing is called process lifecycle owner. I'm basically tinkering with the lifecycle components, and I find something called process lifecycle owner. Now, this class basically, in general, the theoretical version says that it tracks the lifecycle of the whole application process. To get this working, you need to have something called lifecycle extensions as a dependency. Now, it does something weird. The weird thing that it does is, as soon as you add lifecycle extension library as a dependency line and you build your project, it automatically adds a provider element to the merged manifest. This is how it looks like. For those of you who don't know how to get to this one, you just open up your manifest, and there's a tab here that says merged manifest, and you can always see the merged version of your manifest file. So it does add something. This is for the Droidcon Boston application that I was working with, but in general, it just added this new provider element. We're going to look at example version of the same thing. And I want you to focus on something here called the process lifecycle owner initializer. It's a content provider. And then there's an authority string. Funny thing about this authority string is that pre-Android X, it was called lifecycle Trojan. For some reason, the Google developers decided to make it lifecycle-Trojan. And people didn't like it. So this is an actual screenshot of a Reddit post. Someone reported by saying that one of our customers is looking at releasing an app with our library. It's just gone through their security testing. They have flagged it as a certain content provider that is listed in the manifest of the generated APK, and it's called lifecycle Trojan. So security teams just didn't like the name at all. So with Android X, they fixed it, and it's called lifecycle process. So it's a funny thing that happened over a period of time, but as library developers, we make mistakes, which is fine, but you fix it with new version upgrades. The same way I think app developers would do it too. So yeah, people were happy with this. So we were talking about process lifecycle owner initializer itself, and what I did was I basically looked into the source code again, and it was doing something weird, as in it does extend content provider because it's a provider element, but in the onCreate, it was initializing something called process lifecycle owner, and it could get the context obviously there. Now, that is weird. Why would it do it? Well, it tries to do it because it wants to invoke process lifecycle owner as soon as possible, as soon as the process starts. Basically, it adds the provider element even if you are not using process lifecycle owner. If you added the dependency by mistake, it's initializing a library even though you don't want it. So that's a drawback with this. How do you get rid of this is the important part, because I'm going to shift away from being a library developer but into an app developer now. And as an app developer, if I have a library which is adding something to my merged manifest file and it's initializing itself, it's probably going to slow down my app from initializing, right? There are multiple libraries that are trying to initialize themselves at the startup of the app, and it's really bad. So I really want to get rid of it. How do you do that? Well, there's something called a merger rule marker. So you have to mark that specific tag, the XML tag in the manifest file with something called tools, :node remove. How do you do that? Well, I literally copied the whole provider. I removed the other parts of it, but what was important was I need to understand that this is the right provider. So I take the Android name and Android authority section, and then I add the tools XML namespace, and then the node remove section. Because of this, when I do this, and I put this into my app's manifest file, when the merger phase goes through, it knows that this particular kind of provider cannot exist at the end of the merger rule. So the provider never ends up, process lifecycle owner never initializes. Although, if that kind of a thing is being employed by the library, this also means that if it doesn't get initialized, either the library developer should be handling this kind of a case when there's no context available, or your app will crash because it didn't get what it was expecting. They are expecting the context to be there automatically, but if it's not there, it's not gonna run at all, and your app will crash. Again, the losers are the app developer. As library developers, this is more like a caution that they should be taking care of. So yeah, this is the signature, and then the section that I was using. So based on this whole idea that I'm looking at, this is what I thought. What if I could do the same thing? Because I would love to do it. The reason being, I would need the Android context for doing a lot of things. I could use it for hooking into the Android runtime. I can do it for accessing the app resource. I could do it for using the system services. You need to call context.getServices, and then maybe register a broadcast receiver like on boot completed or something like that. And I want to do this automatically the same way as process lifecycle owner is doing. So the usual way what people have been doing up till now is this. You create a custom my application class, extend from application class, and then you go in and initialize your library inside the my application class. Eventually, you have to go into your manifest file and add the custom my application class. Now, that's a lot of work. I didn't want to do that. So what I did was I basically thought about the process, and I wanted to figure out why is a content provider being used. So a content provider basically is being used in the process lifecycle owner, the library, to simplify the process. That's because content providers are created and initialized on the main thread before all other components. It's like the first thing that will ever get initialized and also created. And they also participate in the manifest merger, merging at the build time. So that's the thing. So I tried to do the same thing. I exactly replicated the way that they were doing it. I created the awesome lib IT init provider, and I extended from content provider. In the onCreate, I got the context, and I initialized my awesome library. Now, when I do that, that is where I get the context. But in my manifest file, I have to go and put in the provider too, because that's what it understands, right? It needs to go through the merger phase and put it back into the application. So I put the provider section here. The point I want to look at is the awesome lib init provider is the content provider that I was talking about. We just made that. And the second part is this authority string, and it has something weird here. And it has something called application ID in a curly bracket with an ampersand sign or a dollar sign. That's because it's basically pulling in the package name of the application and appending it or prepending it to the awesome lib init provider string. Why am I doing that? Because I need to make this authority string as unique. I'll talk about why that is required. So I do that, and basically everything works the way I want. Now, I said content provider can be used to simplify the process, but there are challenges. The challenges being the authority string actually is enforced to be unique. If it's not unique, this is what happens. You have a library that doesn't have a unique content provider authority string. It goes into an app A, and the app A is installed. Super nice. When it goes into another app B, and on the same device, the app B is trying to get installed, is when things will actually go wrong, because it will say that there's a conflict with the authority string, and the app B will never get installed. So technically, the app developer did not do anything wrong. They were basically built their app, and they just integrated a library. That library basically made sure that it never got installed in other devices. So it's like a race condition now. If app A got installed, app B cannot get installed. If app B got installed, app A cannot get installed. If there are more apps, only one of the apps whatever is getting installed on that device. So it's a problem. Also, because we are trying to get the context, it can only run on the main thread, although there are possibility to do it like multi-process, which you would have seen in the process lifecycle owner. They mentioned a tag that says multi-process true. That basically means that every time a new process is instantiated, you can create another content provider for it. But it's not going to give you the context that you are requesting as a library developer. You basically do some sort of AIDL, inter-process communication, but you don't want to get into that. Now, here's the thing. It does simplify the process, but that's not a good thing to do. Why is this bad? Because if 5 of these libraries did the same kind of thing, initialize at the same time, your startup time basically just increases exponentially. The second point is what I was talking about. Even if you don't want it, that library provider is getting added, and it's getting initialized for no random reason, right? So it's bloating your application. And the third one is very specific. You're obviously abusing the functionality of content provider. Content providers are used to like talk to databases versus what we are doing is trying to get the context out of it, which is really bad. Now, the solution for the increases startup time is that you can use async initialization, which is pretty much, I think, what people should do in the first place, not even considering the content provider. A general library should also initialize itself in an async manner. For bloating the application, even when not used, the solution is more or less using the tools remove node. You're already abusing the functionality of content provider, so there's nothing to solve there. But process lifecycle owner is not the only library that is doing this. A lot of other libraries are doing this. So you have process lifecycle owner, the one that I talked about. They have this provider string. You have Firebase, which in general, this is a commons library that I took specifically, but when you include the Firebase analytics, Firebase common gets pulled into the system transitively, adds this provider. Facebook has this thing called Facebook core, again being pulled as a transitive dependency, adds a provider to your application at the end of the merger phase because of a library. Facebook being Facebook has another library called Facebook Marketing, which does the same thing. So it brings us to the same state that I was talking about, like 2 libraries doing the same kind of things would increase the size of your, or the time of your app initialization. So Facebook does this. Then you have Crashlytics, which is pretty common. Everyone knows that, but people don't know that they're initialized during the time when the app is actually loading up. So this is how they do it. They use the process lifecycle, the init provider method. I was talking about Picasso, right? This happened recently. So Picasso, earlier, before like version 2.7.1A2, I don't know why it's a weird name, but yeah, it is. You used to do something called Picasso with this. You have to pass a context every time you need to access it. With version 2.71828, they just removed that. So it's no magic. Well, basically, they have a provider now. So this is how everyone is doing. So every other library that you can think of nowadays are using these kind of things. And they're not evident right up. It becomes visible when you start to look into the source code or try to tinker with these things. So we find those because like I work with libraries, I build those, so I have these opportunities to look at these kind of codes. But in general, like most of these things, they don't have a rule book. It's not written anywhere to use it this way. But sometimes people just come up with these kind of hacks because content provider is sort of a hack, but if it works, people are going to use it. The idea is that usually only the ones that are used for analytics, like Crashlytics is a good example. Firebase is also a very good example because using for your Firebase analytics. Process lifecycle owner is a very good example. If they are doing it, it's good because they need to do it as soon as the process starts. But Facebook marketing doesn't make sense. Picasso, on the other hand, is doing some kind of other like changes in the process. I'm not sure if this is more supported right now, but maybe it might change. But this is right now in the master branch, so I'm assuming it's going to be supported. But it is obviously doing something to your app, like getting a context upfront. So it's good to know that, OK, something is initializing at that time. With that, I think I am done with the talk. So I have references here, links to libraries that I've built. There's an example of showing how you can make your library auto-initialize. And then there's an example about how you can get the lifecycle-aware version of your library, which you can do it. Yep. And that's it. Thank you. I do have 2 books to give away for Raven if you guys ever is interested, I have one for Kotlin and one for Android. So if you guys want that, I could give you that too. Thank you.
Thank you. We have 15 minutes for questions, please.
Hello, thank you for your talk. There was a slide where you show your library easy device, I think, where there were POM file with Google Ads dependency and your base dependency. One was marked as runtime and another as compile. Do you have any recommendations when you have to put compile, runtime, or provide it as a scope methods?
So it comes down to the same thing that I started with, how Gradle processes these libraries. So you have this API version, the compile-only version. The one that you see runtime is for the compile-only marked one. So in build.gradle for Google Play services, this probably would be something like that says like API or compile-only. In my case, I literally put compile-only in the ads module. So it turns out in the POM file, it says runtime in the tag section. It just tells so again, POM file is supposed to tell how to build the Maven artifact. So when it is doing that, it tries to understand the same kind of things that it was able to do in build.gradle. So compile is going to compile standard way of compiling that will just basically pull the library in and compile it. For when it comes to the Google Play services or the ads identifier, the one that I have, it will say it should be available to me during the runtime, and I'm not going to download this. So in theory, at this point, the app should have implemented the ads identifier. So as a library developer, I'm not doing this magically. I'm enforcing this that if you ever want to get this functionality, you need to do it on the app side so you know that you are pulling in the Google Play services. So this is more like a recommendation here that instead of the reason people use compile only nowadays is to not do magical stuff, but enforce it on the app developer side so that they know that in their app, this thing is getting pulled in. If, say, for example, I went in and I did something like implementation play services, then as an app developer, you would never know that it was getting downloaded because this was not enforced and you didn't add it in your build.gradle itself. So that's why it becomes very much evident that using compile only is important when you want to convey this back to the app developer that, okay, if you want this functionality, in my library though, I'm handling this condition. How you handle that is a different topic, but the general idea is you check if the class is available in the class path. If it's not, then it's not available in the compile time, so I just disable the whole library. The app developer, on the other hand, is just adding that line and my library, and everything should work out of the box.
Thank you. Questions? Пожалуйста. Okay.
Hi.
Hi.
Thanks for a great speech. That was really interesting. May I ask you to show slide number 34?
Yes. I have a lot of these. I could have just gone another way. Let's see, I can just jump right here, no?
That was about ProGuard rule.
This one?
No, previous.
This one.
Yep. So that flag will affect all application which will use your library, right?
Yes.
So is there any way to check? We have a manifest and we can check merged manifest. Is there any ability to check merged ProGuard rules?
Right here.
Ah.
Yes.
Okay.
So you put this inside your app's ProGuard rules file. You say when the merging is going to happen for my app. At this point, print the configuration into the ProGuard merge configs.txt. So this file will get generated. It's almost like the same way you would do for printing your seed files or your obfuscation when you're doing that. So you need to see the mapping file, right? Mm-hmm. So you do print mapping and then the mapping file. Here you are saying print the configuration and the configuration file. At the end of the whole build process, you will get this file which will have your ProGuard rules, as well as if, say, for example, you have 10 libraries and they each have their own ProGuard rules, they all merged into one single file. This is the one that you will get.
Okay, great. Thanks a lot.
Yeah, welcome.